Welcome back to the channel. So today's question is number of ways to assign a edge weight 1. So the question requires two things. First is find the maximum depth of the tree. The another question says itself is the number of ways to assign the odd weight. So how do I got to know about all these things? That is clearly mentioned in the question. You have to just read the question. You will find out that it says about 1 to x the depth, which is gonna give us the maximum depth, and it clearly says that assign the odd weights to the tree. So how we are gonna solve this question? Let me clarify you with an example. Now start with a try run. So in this, the first requirement is the depth. So what is the maximum depth? Can you see? So I can say this is the maximum depth, which I can say which is 2. 2 is the maximum depth. Alternately, this is also a maximum depth, which is also 2. So you can either choose x as 5 or x as 4. It's totally depends on you, and it doesn't matter whatever you choose. Now the second point is how we are gonna assign the values. This is the first, second one. So how we are gonna assign the value? So as you can clearly see that if I select x is equals to 4, so the edges I got, this is the first edge and the second edge. So in the edges, as these both are the edges, this is E1 and E2, in how many ways I can assign the odd values to them. So the thing what I can see is I can assign 1 and 2. So they will give me an answer 3, which is an odd one. And one thing I can also do that I will assign 2 over here and 1 over here. So it will also contribute to the odd one, which is gonna give me the 3. So the total combination I got is 2. Let me clear it for you to make it more understandable to you. So the thing that we have seen earlier, it is that we are gonna use a maximum depth. We are gonna find the maximum depth. For maximum depth, we can use DFS. I know you know DFS clearly. If you don't know, you can check out videos for how to find a DFS in a tree or in a graph. That will basically make your understanding better. The second case is that we have to assign the values in order to find the odd values. So these are our x. So I choose 5 as an x. We can choose only one x. So I am choosing this path. So the two ways I share with you is that 1, 2 and 2, 1. So DFS, I will just write the DFS code directly, and I will understand you how you can implement DFS. So assign values, it is an observation part. Let me make it understandable to you with multiple examples, so you can understand how we got the assign values, the permutations of number of ways in which we can assign values to it. So let me do it for you. So let us understand the observation of odd values in the edges. If the edge size is 1, if there is only one edge, so how many ways you can assign odd values? There's only one way, directly assign 1 to it. So for edge 1, there is only one way, assigning 1 directly to it. If the edges are 2, so we can assign 2, 1 and 1, 2. There are 2 ways to assign values. So we can say if the edge is 2, we can assign in 2 ways. Now if the edge is 3, if there are 3 edges, in how many ways we can assign? We can assign 1 odd, which is 1, and make both of them 2, or else we can make 2, 1, 2. It's just a hit and trial method. You can do it by your own. There's 2, 2 and 1, and there's one way also. We can assign 1 to all of them. So there are 4 ways to do that. I'm just doing with multiple examples to make one thing clear, which is an observation part. You will understand when I will do for all the edges. So with 4, how many ways we can assign one 1 to 1 place, and all remaining all are 2, and likewise 2 1 2 and 2 2 2 1 and 2. These are the permutations. You can use directly permutation formula for 1s and 2s, but that is gonna give a overflow condition because the constants are very high, which is that I'm talking about. You can use n factorial over 1's occurrence factorial over 2's occurrence for factorial. That is gonna exceed the memory limit, so that's why we are not using it. Now here is 2 to 1. So these are the 4 ways of doing that. Now comes now there is also a way to assign odd values, which is I can assign 1 1 1 and 2 over here. So it will also give 4 ways. It will also produce 4 ways. So the total ways are 8 of doing that. If you are observing it, you are getting one thing, which is power of 2. This is 2 power 0, this is 2 power 1, this is 2 power 2, and this is 2 power 3. And check it for H5 if it is gives 2 power 4. Let me do it for you. That's a nice observation. If you observe it, you have done the question clearly. So now I will do it for 5. So in how many odd ways I can assign odd values? First make it 1 over here, and all the remainings are 2. So this is gonna give me 5 ways. This is gonna give me 5 ways, which you can do also 2 1 2 2 2, and likewise 1 over here, then 1 then 1. So all these are contributes to 5 ways. 1 2 3 4 5. Now I will try different possibilities to make it odd, which is gonna give me, I will assign 3 values over here and 2 over here. So the formula I discussed with you earlier, which is n factorial over 3 factorial over 2 factorial. 3 represents the 1's and 2 represents the 2's. So here the value of n is 5 factorial. That's a permutation formula. You have studied it earlier in your classes. It's tell about the total arrangements of the numbers with repetitions excluding it. It's 3 factorial over 2 factorial. 5 factorial, I can write 5 factorial like the 5 into 4 into 3 factorial. 3 factorial into 2 factorial is 2. 3 factorial cuts 3 factorial, 2 factorial cuts 4 by 2. So it's give me 10. So the another possibility I got is 10. Now try the final possibility, which gives me the odd value, which is making all of them 1. So it is only one way of making all of them 1 is 1. Assign 1 to all of them. So that's become 1, and that is also become 1. Let me write it for you. So there's also one way. So the total ways I got over here is 16, and so I got 16 over here. So you can see that it is 2 power 0, it is 2 power 1, it is 2 power 2, it is 2 power 3, it is 2 power 4. So we are just gonna iterate from I0 till I less than, if it is 5 then 4, which is gonna give the power value. So n minus 1, and just use the into 2, it's just the power formula of 2, and we got our answer. So let me code it up for you. So I will create a adjacency list, which will denote the tree. Here I have built a adjacency map. I have built an unordered map, which is an adjacency list, and it is storing the edges from U to V and V to U. As it mentioned in the question, it is an undirected map. Undirected tree, sorry, it's not, it's a tree. I have assigned this. Now I will make a DFS call to find the height of the maximum height of the tree. So I have defined the function for the DFS, which gives me the maximum depth of the tree. So I will write the code, then I will make you understand how this function works. So now let me understand you how DFS gonna work. So I have built the adjacency list. This is our adjacency list. Now let's move from the 1, as 1 is the root mentioned in the question. So 1 will move to 2 directions, which is gonna be 2 and 3. So here I have write that node 1 will move to 2 and 3. So we have moved towards the 2. Then 2 where height is, so the height will be 1 plus the DFS of 1. Why DFS of 1? Because 2 is, we have considered 2 as a height, which is gonna 1, and it will traverse back to the 1, which is already visited. So there we got written 0, because when we came from 1 we mark 1 as visited, and when we are in 2 we will just check for its neighbors. So it has neighbor which is 1, which is also mentioned over here. So 2 has neighbor 1, which is already visited. So for this DFS the value is 0. So from 2 we got the total height is 1. So I can say that from 2 I have written 1 as a height. Now 1 will move to 3, then 3 will check to its neighbor, it will go to 4, and it will go to 5. When it goes to 4, it will say the height is 1, 4 will return the height 1, 5 will return the height 1 as well, and 3 will choose the maximum. So the maximum of 1, 1 is 1, so 3 will return 1, its height plus the children's height, which is 1, so it's gonna give us 2. Here it returns 2. So the two things I got here, it is 1 over here and 2 over here. So it will return the maximum of 1, 2, which is gonna be 2. So here I return 2 plus the height of 1, which is 3. So I got 3. That's how the DFS is gonna work. Let me tell you in this code. So we have called the DFS from root 1. Here I have initialized the visited vector of n plus 1 size. Initially all are 0. So at starting we considered root 1 as 1 and the height is 0. It will check to its neighbor. If they are unvisited, it will make a DFS call similarly and find the maximum height out of them and return at the end the height we got at the final. Now let me apply the function which is the observation part. So I have made a function h which is gonna give us the values of ways of assigning the odd values. So the function h, which is gonna gives the total ways of assigning the odd values, it is just like that. So we will return answer at the end. Each time we are gonna multiply with it 2. As I told you, we got the observation. So here's the observation part. As you can see that clearly we have traversed from 0 till h minus 1, and each time we are multiplying with it 2, the answer. So we are getting the value, the power of 2. So that's the way of solving it. So I have successfully submitted this question. You can check out the code in the GitHub link. Now talk about the time and space complexity. So let us discuss the time and space complexity. So if we have a tree of n nodes, we are building and traversing to build the n nodes. So we are traversing on all the nodes to build a tree, which is gonna give us the big of n complexity to traverse over building a tree. And when we are using when we are moving I from I to h minus 1, so it is also a big of h minus 1 time complexity, which is gonna give us over time complexity of big of n. So the time complexity is big of n. Now talking about the space complexity, we have used the visited vector in the DFS, which is the only extra memory we have used. So its space is n plus 1, which is contribute to big of n. So we can say the space complexity is also big of n. So that's the space and time and space complexity. Like, share and subscribe, and the code is in the GitHub link. Thank you for watching the video.